Hi everyone, my name is Muhammad Khalafallah, and in this presentation I would like to explain how the crude oil price fluctuation would affect the future asphalt prices. As we can see now, from this last pandemic, the prices of oil got affected tremendously. So if you work in the construction industry, or as a DOT, for example, you want to know how this change will be translated, or how this change will be translated to the construction industry, or in terms of asphalt, for example. How would that happen? So let's see how this is being explained. So just to mention, this research or this presentation is based on the paper that was presented in January 2020 in the annual Transportation Research Board meeting in Washington, D.C. So general overview of the presentation is we're going to talk about a brief introduction about our topic. Also, we're going to talk a little bit about the methodology that was used to do the research, and how we collected the data and how we analyzed it, and finally the conclusions from our research. So let's jump ahead. So what was the motivation for our research? Of course, asphalt is a major cost component in construction. With more than 94% of the roads in the United States are paved with asphalt. And 40% of the roads, or the budget of Alabama Department of Transportation, goes to asphalt. I just mentioned Alabama Department of Transportation because the data that we're going to use here in this research was based on the data that we acquired from Alabama Department of Transportation. With also $80 billion spent annually on asphalt across the United States. And finally, that asphalt is a very volatile commodity. So, for example, if you look at, like, in 2008, there was a sudden bump in the prices of asphalt, which forced DOTs to stop a lot of these projects. So just to mention the relationship between the asphalt and the crude oil, since asphalt is a byproduct of crude oil, we know that crude oil prices have a direct effect on asphalt prices. So this is also part of the motivation of the research. You can classify oil or crude oil into light and heavy. And so the light, well, you get like the jet fuel, the fuel for the vehicles. And with the heavy, when you start to get the diesel. So the last one, or the heaviest part of the oil, is the bitumen, or what we use to form the asphalt in the asphalt paving. So the research objectives, after we considering asphalt and crude oil price indices, are three main objectives from this study. So the first one is to identify the time gap between the crude oil index and asphalt index change. What that means is, if, for example, a sudden change happened in the crude oil price index, how long will that change translated into the price of asphalt? And the second objective is to get the percent change ratio between the oil and the asphalt. Meaning that if that change happened and we were able to get the time gap, okay, how can we measure that effect? I mean, if the prices change in crude oil like by $1, so how much of that dollar would be reflected into the asphalt? And the last objective is to create a risk assessment tool based on these two objectives. So the data collection, we collected our data from Alabama Department of Transportation and the WTI, or the West Texas Intermediate Crude Oil Price Index. We got the WTI information from the U.S. Energy Information Administration, and we got the asphalt prices from the ALDOT website. So we can visually see here that the gap between the asphalt and the crude oil is about between 3 to 5 months. So you can just see also from the graph that actually asphalt is just shadowing the crude oil trend line. So what we used is, to get the time gap, we used what we call the cumulative sum method, or the QSUM method, to detect the small shifts or the trend shifts in the data. So what is the QSUM method? So the QSUM method, described by Bodie and Smith in a paper that was published in 2009, as a statistical hypothesis testing technique that could be performed to detect critical points. So the method, as it is right now, it identifies a trend, or whatever trend happens, change happens in a data series, a series of data, but only can detect that if the data has a trend line that is horizontal. So if you look, this is the data on the left side of the graph on the screen. So the right side is when you plot the QSUM method. So for example, it will tell you this is the critical point here. So you go back to the original data series, and you'd know this is the critical point. So what we did is we had to modify the method to detect the critical points in asphalt and crude oil indices, since the trend line is actually not following a horizontal line, as we can see in our example. So what we did is we created an algorithm that to transform any prospective trend segments into a horizontal trend line for the QSUM to work. We used Pythagorean theorem to find the transformed vertical component. Multiplying the vectors was used to multiply the vectors was used on vector AD and AB to use a dot product equation. Other things you don't need, I don't want to go deep in details about it, but the main idea is we transformed every trend line that is going upward or downward into a horizontal line. We came up with a possible points in both trend lines for asphalt and crude oil, about 9,180 points. So that makes it a little bit over 18,000 points, since we have two trend lines. So what we did is we include both critical points on one figure here. And you see when we circle, these are the critical points for what we were able to identify for crude oil and asphalt. So we were able to identify 23 points for crude oil and 26 points for asphalt. So the next stage now from this graph, we want to get the results. So what we were looking for the time gap, remember guys, and the percent change ratio. So the time gap is here. We just measured the horizontal difference or distance between the point or the critical points in the previous graph. So if you just go back again, if you look at one of these circles, if you look at the horizontal space, this should be the time gap. And we plotted all the data here. And we found that at least 54% of the time gap was about 3 months in this probability distribution plot. So now let's go to the other requirement here. So how can we get the percent change? So we use the slope relationship. So we pick the trend line in the crude price index, and then we compare it to the asphalt price index on the other trend line, and we get the slopes of both. And then when we plotted the data, we found that the average percent change ratio is about 58%. What does that mean? Is if it happened, let's say if a change happens in the crude oil price, if let's say the oil of barrel like changed by $1, so how much of that dollar would be affected? So we know that 54% of the time, this time gap would be 3 months. So we know that the change will happen after 3 months in the asphalt, and the change will be about if it's $1 in the crude oil, so that $1 will be translated into 58 cents. So the asphalt price will actually change by 58 cents as a result of that dollar change. So what we did is also to cross-validate our findings. We used 2 studies to compare their findings with our findings. So how did we cross-validate? Before I dig deep into this, remember we said like we used data from 2006 to 2018, but actually we used from 2006 to the end of 2007. We used the last year just to cross-validate our findings. So we refer to the 2 studies as study 1 and study 2. So the 2 studies found that the time gap is like 1 and 6, and the percent change is 130% and 70%. So as I said, we use the last 12 months for validation. So what we used actually is the MAPE, which is the mean absolute percentage error, and the standard deviation. So in both studies, they had MAPE as 5.5% and 3%, and we got it as 2.2%. So that means our data is more reliable than theirs. And the same thing happened with the standard deviation. So lastly, to come up with the risk assessment tool, we had to, we combined both findings. So on the left side, we have the time gap, and on the right side, we have the crude oil price fluctuation, or the percent change ratio in the crude oil price into asphalt. So we came up with this matrix. We joined the 2 probability to get this matrix that tells you how the change will be reflected in the asphalt. So just to give an example of how we would use that risk assessment tool, let's say, for example, that between January and February in 2018, there was a decrease of 2.3% in the crude oil price index. So how would that change would be affected? How would we use that change in this matrix? So the table will be shown as filled as follows in this picture. And if we want to interpret the data, we can say that from the figure that percent change in crude oil price index would mean that there was a 14.2% probability of having this fluctuation reduce the asphalt price index between 0.9 and 1.4% by May 2018. So the summary of the findings is we found the time gap to be about 3 months and the percent change ratio to be 58%. And when we did the cross-validate our results between the 2 studies, that we find our study performed better than both of these studies. So the limitation of our research, so the findings that we had or we came up with was only based on the asphalt prices acquired from LDOT. Of course, the same methodology can be applied to any type of data, but with this, just with these findings is only applied to the data or projects in Alabama only. One of the other limitations is the visual inspections, because pairing the points together added some subjectivity to the process, which means that different researchers could select different pairs of points and therefore to obtain different results. So it would be best if we can come up with an automated way of pairing the points. So future research objectives, it would be, of course, to replicate the same study, but for other state agencies, or maybe we could do one on the national level. So also eliminate the need for visual inspection of pairing the points. Also, it would be very good if we can develop a user-friendly system that can consider not only observe crude oil index fluctuation, but also consider the factors influencing the asphalt market. Thank you guys for your attention, and I hope you liked the presentation and find it very useful. Please, you can send me if you have any questions.